Welcome back to the GCSE Maths Pro YouTube channel. In today's video, we're going to go through trigonometry past paper questions from EDEXCEL that are the most common ones, particularly for higher tier. So this video will cover a little bit of everything to do with trigonometry. So first of all, you can see we're starting out with question number 7, so towards the front of the paper. When it's towards the front of the paper, it's more likely to be SOH CAH TOA type of trigonometry with the right angled triangles instead of Sine and Cosine Rule, which are obviously at the end of the paper. For each exam question, I will put the paper here in the corner so you can also reference it yourself as well. And you can see at the bottom the number of marks that you would get. So, question 7, we've been given that ABCD is a trapezium. However, you can see that they've kind of split it up to show that we've got a triangle there as well. They're asking us to work out the size of angle CDA. That's where you would go start at C, go to D, and then to A. It's the angle in between that, so obviously here. So we put a little X, that's what we're looking for. Give your answer to 1 decimal place. Fine. So just looking at this, they haven't mentioned trigonometry at all. Obviously you know it is because it's in this video. However, they don't often mention that it's trigonometry. How do I know it's going to be that then? Well, trigonometry, and obviously Pythagoras as well, is always to do in this early stage in the paper with right angled triangles. And you can see that they've clearly drawn one here. So even though it is part of a different shape, you can still create any triangles throughout this shape that would be helpful to you. So we're obviously looking to get the angle over this end, but there's no information really around here. So I'm going to obviously start to the left. I've got more information going on there. With any question in the exam, you can always draw things on it. So what I mean by that is I could add some more lines if I wanted to. When I first look at this question, I'm thinking we might have some trigonometry because they've highlighted a right angled triangle, but also I kind of go through a process of elimination if I'm not really sure initially. We're asked to find an angle. So what do I know about angles in general? Could I use anything to do with just angles in a quadrilateral? Would that be enough? Could I use angles on parallel lines, things like that? A trapezium, these are obviously parallel lines. That's kind of what's roughly going through my head if I'm not really sure what to do in a question. Now, those two topics don't tend to rely on actual lengths and measurements. They're just purely degrees and angles, aren't they? So the fact that I've also been given not only a triangle here, a right angle triangle, but I've been given these different side lengths, that's kind of what makes me think it would be trigonometry. So I can draw on any additional lines, create any additional shapes that are helpful to me. In this case, I think drawing another vertical line here from the point C straight down would be helpful because then I've got another right angle triangle on the right hand side. Now I know that because this BC section in the middle is basically a rectangle, isn't it? That the height of that would be 6 centimeters. So I've already got that information. Now it's to figure out, okay, well, if I were to use trigonometry here, I need 2 sides in order to work out an angle, don't I, with SOH CAH TOA? So I've got one side here, 6. However, I would need either CD or the base of this triangle. So that's where I then look at all the rest and go, okay, well, why have they given me all these other pieces of information? Because they won't give you anything that you don't need. So technically I've used the 6, haven't I? That logic. But what else has been given that I haven't used yet? So is it easier for me to work out this hypotenuse or the base of the triangle? Based on the fact that they've told me the top and bottom measurements of the trapezium, I'm thinking it's probably easier to work out the length of this first. Then I can work out the angle. The other clue is, do you see how it's 5 marks? That's quite a few steps of working out. So I might need to work out a few other things first before I get directly to my answer. Now I'm going through process of elimination. How do I work out this base of the triangle? I know that the whole trapezium is 24 centimeters. I know that BC is 10. Okay, now that's why they've highlighted this triangle on the left and the 7.5. If I could work out this length, then do you see how I could do 24 minus the 10 centimeters minus the blue base, and it would leave me with just the yellow bit. So that's why they've given me this triangle on the left. So that's where I'm going to start. In my head, I've just kind of worked backwards to figure out my plan of action. So looking at this triangle over here, I want to know the base, but I have actually been given 2 other sides. I don't have any angles, but I do have 2 out of 3 sides, and I'm looking for another side. So actually that's Pythagoras, isn't it? When you've only got sides, no angles, and a right angle triangle, that's Pythagoras. So I'm going to label it. C is always the hypotenuse, and then A and B don't really matter. So I'll put A here, we'll put B here. First step, Pythagoras' theorem. A squared plus B squared equals C squared. Now fill in the numbers that I know. We're finding A squared. We know B squared is going to be 6 squared, and then C squared is 7.5 squared. As you can see, this is paper 2, which means it is a calculator 1, so you would just then put this in the calculator. So I know in order to get a squared, I need to do 7.5 squared minus 6 squared, which is 84/1 or 20.25. But don't forget to square root it at the end. So square root answer 9/2 or 4.5. So there we are, A is 4.5 centimeters. So now I can write that onto my diagram. You can label your diagram as much as you like. Now that I've done that, my step 2 is then to go back to working out the base of my other triangle. I know that the whole base of the trapezium is 24, and then it's also made up of a 10 centimeter and a 4.5 centimeters. So I'm going to just subtract those from the 24, which should give me 9.5. So do you see how that's why I know that the base of the triangle on the right is 9.5? Because I've taken the whole base of the trapezium and subtracted 2 other parts. Okay, now the last thing is I can actually focus on this triangle and working out the angle that I want. Because we've got a right angle triangle and we're looking for angles, it's now trig. So when I label the triangle, we want to label the 2 sides that are relevant to us. So obviously the 6 is relevant because we know what it is, that's the opposite. And the 9.5 is relevant, which is the adjacent. The hypotenuse in this case, I mean that is the hypotenuse, but it's not relevant to the question, is it? So I'm not going to label it. The reason why I only labeled 2 for trig is because then when I go through which one of SOH CAH TOA is it, I can see I've got O and A. Therefore it's TOA, which is tan. And I know the formula for tan, so tan of the angle x is opposite over adjacent. You might use the formula triangle, that's fine. You can see we're working out the angle, cross that out, opposite over adjacent. So 6/9.5. Now the only thing with this though, if you type in 6/9.5, 6 divided by 9.5 in your calculator just as it is, do you see how you end up with a number less than 0? Think about it logically, is the angle going to be 0.6 degrees? Very unlikely, right? So we're actually missing something. Whenever we work out the angle using any version of trig, whether it's SOH CAH TOA, whether it's sine, cosine rule, whatever, we always have to do the inverse of, in this case, tan. So you see where you've got sin, cos, and tan in your calculator. You've got above it sin to the power of -1, cos to the -1, tan to the -1. That's the inverse. Because I don't want to work out what tan x is, I want to work out just what x is. So how do I cancel out the tan? Well, the inverse of tan, right? So what I would actually type into my calculator is tan inverse. You press shift and then the tan button. You see you get the -1. 6/9.5. And then do you see how I get an actual, like a more decent answer? 32 degrees seems more reasonable, doesn't it? They've said round to 1 decimal place, so 32.3. And there's my answer, 5 marks. It's 5 marks just because there were so many steps. We had also Pythagoras as well. So a bit of problem solving there. When you have a bigger shape or like 2 triangles stuck together, you might have multiple steps. Okay, the next question, we are jumping ahead a bit. You can see now we're on question 18, so we're towards the end of the paper now. We've now got a 3D shape. Now initially you might not think this is to do with trig because there's no triangles to be seen currently, but that doesn't mean that again we can draw them on. So this one they've just given us the information here, they haven't labelled it, so I'm going to go through and just write on the labels. And you see they've said angle BCA, so I'm obviously going to draw that by drawing a line from C to A myself. There, so then the angle is here. You see how that's flat on the base of the cuboid. It looks a bit like a cube, but they have said it's a cuboid, okay? So just don't think it's all the same measurements all the way around. The actual question is, find the size of the angle between AH and the plane ABCD. So this is really common for, this is obviously a 3D trig question because we've got a 3D shape. 3D trigonometry isn't any different to SOH CAH TOA. It's just the fact that you've got like a 3D shape around it. You're going to have triangles that are 2D inside of the 3D shape, if that makes sense. So it's nothing different, it's just in a different context. So they've said the angle between AH, so that line, I'm going to draw that one as well. And then they've said the plane ABCD, which the plane means the side or the surface, right? So you can see that that means the base of this cuboid. What angle is that actually referring to? Well, this one's a bit easier because we had to draw the line CA. The angle is this one between AH and AC. AC represents the plane ABCD because it's going straight across it. It's kind of crossing through the whole thing, isn't it? Some people might think, if I rub that out really quick, some people might think that that means the angle like this. You see how it's going to AD? But if you think about it, that's kind of like a weirdly diagonal angle, isn't it? It would never be a diagonal angle. It'll always be vertical or horizontal, like flat or stood upright. This is kind of awkwardly diagonal, isn't it? So it's not that. So if you ever get this question where it says between a line, obviously draw that line, and then a plane, draw a diagonal line across the plane, obviously where it connects with your other line that you drew. So do you see this green triangle here? It's still a 2D triangle. It's still a right angle triangle, because we know here is a right angle. Do you see how it's kind of stood upright, going just straight diagonally through the cuboid? That's a triangle, isn't it? You can use that for SOH CAH TOA. So we're just going to look at our cuboid and figure out different right angle triangles that we can use, obviously with trigonometry, but also sometimes you might need Pythagoras as well, because that is still related to right angle triangles, isn't it? Just depends on the question. So that's our end goal. Now, thinking back to trigonometry SOH CAH TOA, find an angle, we need two sides. You can see of this green triangle, we've got the side CH, which is the opposite. We need, therefore, one more side. Do we want AH or AC? It doesn't really matter, but as in, which one would be easier to figure out based on the other information that they've given us? Do you see how the other information is down here on the base of the triangle? We've got this 48 degrees, which was angle BCA, and we've got 7.5 centimeters, which is side AB. That leads me to believe it's probably easier to work out side AC than it is AH. So that's what I'm going to do. So if we get rid of our green triangle just for now, and draw the other triangle ABC. So it's kind of hard to see, but that green triangle at the base, the right angle is over here, isn't it? There's the right angle. We've got 48 degrees and we've got a side. Let me draw that triangle separately for you so you can just look at it. There, if we were looking kind of bird's eye view on it, here's the right angle. This is angle B, angle A, and C. We know that this is 48 degrees and this side is 7.5. And we want to know AC. So that is trigonometry, isn't it? We've got some angles and some sides. So we just go through that. Okay, this is the opposite. I want to know the hypotenuse. So out of my SOH CAH TOA, which one is it? Well, that would obviously be sin. Then I like to do my formula triangle to figure out what I'm actually typing in the calculator. I'm looking for the hypotenuse. Cross that one out. So in order to find the hypotenuse, AC, I need to do the opposite side, which is just 7.5. Over the angle. Now the angle in trigonometry always goes with sin, cos or tan, doesn't it? So that would be sin 48. That's what I'm putting into my calculator. This is step 1. So literally 7.5 over normal sin, because I know the angle. I'm not trying to find it. I know what it is. So just normal sin, not the inverse. Obviously I'm going to get a number that's quite long, and I don't really want to write down all those numbers, but I also don't want to round it too soon. So what I normally do is write down a couple of those digits. So 10.092, let's say, ... just to remind us that it carries on. That's AC. And then I will just keep my answer here. Just keep it there in your calculator. Don't get rid of it just yet. So if I come back to my diagram over here, this is 10.092, ... isn't it? This angle. So let's go back to our original triangle, the one that we actually want to find the answer to. So there's our triangle. Now we're looking at the triangle ACH. Obviously the right angle is here. We know the side CH is 8.1 centimeters. We know the side AC is 10.029 ... centimeters. And we were asked to work out this angle, weren't we? So let's say that's X. So now we can go through step 2, label the two sides that are relevant. So obviously the opposite is relevant and this is the adjacent. So we've got tan now. So to find the angle, we always cross out the sin, cos or tan part. Tan of the angle X is obviously opposite, which is 8.1 over the adjacent, which I'm going to write down 10.092 here, but in my calculator, I'm going to copy my previous answer with all of the digits. But remember, that's for tan of X. I actually just want to know what X is in the end, don't I? Not tan of X. So we're going to have to use tan inverse. So do you see how on my calculator, I still have my previous answer there? I can write in tan inverse 8.1, and then underneath, I'm not going to type in 10.092 because I'm cutting off a load of digits. Do you see this ANS button down here? That means answer. As long as it's your previous answer on your calculator, it will copy the previous answer. Equals, this is my most accurate answer. Again, they've asked us to round it to one decimal place, so 38.8. And again, just double check, does that make sense as an angle? Yeah, 30, 40 degrees, that makes sense. There's our answer. Normally with 3D trig, you're going to have to do at least 2 steps, something with the triangle before, to then find out information about the actual triangle you want to look at in the end. Okay, so as you can see, we are moving on now. Still towards the end of the paper, 5 marks, obviously a calculated paper. This time though, we've still got triangles, but do you see how, first of all, they're not right-angled triangles? So it can't be SOH CAH TOA. There's also nothing 3D about it, right? So it's not 3D trig, which is also SOH CAH TOA. So it's not either of those. We've got obviously triangles, we've got some lengths, and then they've mentioned something about some angles. So in my head, before I've even read it, I'm kind of thinking, okay, it's trig, it's not SOH CAH TOA, but it could be therefore sine rule, cosine rule, or maybe something to do with the area formula. And that's before I've even read it. I'm just kind of looking at the question and going, yeah, I feel like that's probably the part of the syllabus we're referring to, but let's just double check. So obviously the diagram shows triangle ABC as a whole. They've obviously labelled the sides there. And then they've said that D is the point on BC, such that the size of angle DAC is equal to 2/5 of the size of angle BCA. That means that angle DAC is smaller than BCA. If you're not sure, I know obviously none of it's drawn completely accurately, but it's not also drawn completely out of whack, right? So if you identify which 2 angles those are, DAC is this one here, BCA is this one here. You can see that this one's obviously bigger. It doesn't necessarily look like it's 2/5 the size of the other one, but you can see which one's roughly bigger. So if you're not sure, it should be more or less drawn fairly well. Calculate the length DC, so this is this small part here. So yes, we've got sides, angles, and just scalene triangles. Scalene triangles are just like random shaped triangles, right? They're not right angle triangles, they're just kind of all of the angles and sides are different. Therefore I know, okay, we're not talking about area either. It's just going to be either sine rule, cosine rule, or maybe sometimes both. Looking at the smaller triangle ACD, if I had enough information in this triangle to work it out, I wouldn't be given the other side, would I? They're not going to give you anything you don't need. So I need to use all of this information. Sine and cosine rule, first of all, require 4 pieces of information. One of those is obviously whatever you're looking for, right? Whatever you're trying to calculate. The other 3 pieces of information you need to know. The difference then between sine and cosine rule is that sine rule is pairs. That means 2 sides, 2 angles. So 2 of each. Cosine rule is 3 sides, 1 angle. So most of the time, the information you're given will fit into one of those 2 rules. So just having a look here. Triangle ACD, I only have 2 pieces of information, the 6.2 and then the one I want to find. So you can see I clearly don't have enough there to do anything with it. So now I'm going to look at either the small triangle ABD, which also only has actually 1 piece of information, so that's not helpful either. Or don't forget you can zoom out and look at the whole triangle ABC. Now, if you have a look at that triangle, do you see how that triangle as a whole has 3 sides? So 3 sides and nothing else. That means that it's more likely to fit into cosine rule. I can't do sine rule without being given another angle. I haven't got any angles right now. So I'm going to use cosine rule because I've got 3 sides and I could use it to work out an angle. Now the angle which would be helpful would be BCA, wouldn't it? Because these 2 are then linked. So that's kind of my process of elimination, right? I'm going to use cosine rule first, which is on your formula sheet, but I will write it here. Now, 2 things about this. On your formula sheet, I'm pretty sure they write it in the context of working out a side. Here, I'm going to use it to work out an angle. So you've got 2 options. Either you memorize the version of cosine rule where cos A is the subject, or you just feel confident enough that you know how to correctly rearrange it to make this the subject. Either of those 2 is up to you. So this is the rearranged version. The second thing is then that they've obviously used A, B, and C. You might have A, B, and C in your diagram, but it might be like that they're in the wrong places. Do you see how we've used angle A? The one I actually want to work out is this one here, which they've labelled C. Now either you can change all of these to the correct ones. I think that's more complicated. What I would do is just relabel the diagram. Put that as A. Therefore, if that's angle A, the opposite side is side A. Fine. B can stay as it is, angle B, therefore this is side B, opposite. And then this A obviously would need to change to be C, therefore this is side C. That's what I would do. And also if they've used PQR, for example, different letters, you can change it as well. So all I'm going to do now is just sub into the formula. Now from seeing the previous 2 questions as well, even though this is not SOH CAH TOA anymore, it's still trig overall. If you're ever looking for an angle, whether it's SOH CAH TOA or cosine rule, sine rule, whatever, you will always have to do the inverse of sin, cos, or tan, because I don't want cos A. I just want to get A, don't I, as the angle. So I'm going to have to do the inverse of cos and then all of this. So again, shift, cos, make sure you get the right sin, cos, or tan, and then just type all of that in. There, close the bracket and put equals. Again, we're looking for an angle, so think, does my answer make logical sense? Is it a fairly decent number? 32 degrees seems reasonable. Because we're going to be using this answer, this is not the final answer, is it? We're going to be using it in our next working out. Again, keep all of your numbers there, don't delete them. Write down a couple, that's fine. So angle, let me write it fully, BCA is 32.08 ... degrees. Okay, so I now know this one. Where do I go from there? Well, I would probably look back to this part here because BCA is related to another angle. So that was step 1. Let's put step 2 over here. Angle DAC is equal to 2/5. You can literally just sub it into this equation, effectively, times by the sides of angle BCA, which is 32.08 ... Now bring back my calculator to see how my answer is still there in full. So I can just go straight into doing 2/5 times and then answer again. So I've copied all of the digits. Now write down a few of these digits. So that one is then 12.832 roughly. That's about 12.8 roughly. So now we've got 2 angles in that triangle. So if I come back here, do I have enough to work out the size of side DC? Which, if I rub these out again, you can see that that was originally DC, wasn't it? So let's not get confused. Okay, now I have not only a side and the side I want, which is 2 pieces of information, I also now have 2 angles. So see how that's like 4 in total, including the one that I'm missing? So I go, yeah, I've got 4 pieces of information now. Does that fit into cosine rule again, or does it fit into sine rule? Let's see what we've got. Well, we've got 2 sides and 2 angles. So that would be sine rule. However, are they actually the opposite pairs? So let me rub out these markings so we don't get confused. X is opposite the angle that was 12.83 ... So yes, that's a pair, isn't it? Those 2 go together. However, do you see how 6.2 is opposite the angle ADC, which we don't technically know? Now, because you've been doing something so complicated as cosine rule and all of this, it can be quite easy to forget how to just work out the 3rd angle in a triangle. I know the other 2. Angles in a triangle always add up to 180. So a little quick step 3, angle ADC, all I need to do is 180 minus both of the other 2, and again, try and remember that they've got some decimals there if you can. So I'm just going to work that out. Obviously, I'm going to copy my whole answer here, and I'm just going to add on 32.08. I don't have all the digits, but that's fine. They normally give you a small range to get your answer in. So that's fine. Add those together and then take it away from 180. So it's roughly 135 degrees, 0.087 ... So now, do you see how I can use that pair? Because I do now know this angle here. And they have to be the angle and the side that are opposite to work together, doesn't it? So I can't use the 32 just because I don't know the side AD. So that was, they've used D, obviously in your sine rule on your exam formula sheet won't say D, so we could call it B, shouldn't we? And then that can be side B. Step 4, grab your sine rule. You will put whichever on the top that you're looking for. We're looking for a side, so I'm going to put the sides at the top. So it's like A over sine A is equal to B over sine B in this particular case. If you're looking for an angle, put the sine A or sine B at the top. Now I can just fill that in. So side A I don't know, I've called it X, you can call it whatever you want, but we don't know what that is, that's fine. Over sine of that angle, which was the 12.832 ... is equal to side B, which is 6.2, over sine of that angle, which was 135.087 ... Now, before we put that in our calculator, we want to find X. So we need that as the subject. So I need to move the sine 12. It's a fraction, so I'm just going to multiply it across. So that's what I'm going to put in my calculator. Again, we're not going to use sine inverse in this case because we're not looking for an angle. So we're just using normal sine. I use my answer button because my 135 degrees was still in the previous answer. You can see we've got 1.95. Now they've said round your answer or give your answer correct to 3 significant figures, which is 1, 2, 3, 1.95. So there is our answer. So it's 5 marks because we had a lot to do. We actually used both sine and cosine rule. Okay, so our last question is now still to do with triangles, still scalene triangles. You can see we've got some angles, we've got a side. So I know it's going to be to do with, more so to do with sine and cosine rules and the area type than it is SOH CAH TOA. So we've always been told ABC and ADC are triangles, but they've actually given us this time the area. The area of triangle ADC, so this bottom one, is 56 meters squared. Work out the length of AB, so that's this one here we want. So some of you thinking, yeah, area of triangle, half base times height. Okay, yeah, cool, that's fine when you know the vertical height, the perpendicular height. We don't know that. So that's why we have a third formula on our formula sheet, which is area of a triangle, but with trigonometry. So you're going to need to use that as well from your formula sheet. Again, we've been given 2 triangles. They want us to find out the side of AB, but obviously, looking at just ABC of the triangle, we've got 2 angles and a side. That's 3 pieces of information. That's not enough to use sine or cosine rule, is it? Either one. Hence why they've also given us a triangle at the bottom and information about the triangle at the bottom. So I'm going to start here with the area formula. On your formula sheet, you should see that there is a trigonometric area formula, which is half AB sine C. Now, this is where we want to, again, rearrange the letters that are here. So in this case, the angle is based with C. Now, if you look at the triangle we've got angle D, the 105. So that one I'm going to call C. And then we want to know side AB. Those are the 2 that surround it, aren't they? Because that would technically be side C, angle A, side A, and then this would technically be B, wouldn't it? Which would be side B. So we've got the angle, and then you want the 2 sides between. So I'm going to fill that out. I've got half. Side A I don't actually know, so let's just leave that. Side B is 11. Sine of the angle 105. Now that equals 56, doesn't it? That equals the area, which we know is 56. So even if you're not really sure where to go with it, at least set up the formula and fill in the information that you know. Because now, if you have a look at this equation, the only thing I don't know is A. So then I'm like, well, I might as well work out side A, because, well, what else am I going to do? So let's rearrange this to find side A. So A is equal to, now what you can do is 56 divided by all of this apart from the A. So 56 divided by half times 11 times sine 105. Again, normal sine because we know the angle. So side A is 10.54 ... meters in this case. So I've worked that out. Okay, that hasn't given me any information about the top triangle still. So I'm still working with the bottom triangle. In this case, the whole shape is a quadrilateral, so it's not very helpful, is it? Like I can't use it as a big triangle because it's obviously not. So I'm still focusing on each individual triangle. So we're still looking at the bottom triangle. I now have an angle and 2 sides. What could I use that to work out that would then help me with the top triangle? Well, the only thing they have in common, because there's no other mention of any other relationships, is the side, I've called it now AB, but it was technically originally AC, wasn't it? The side AC, the one that's in the middle. A lot of the time when you have 2 triangles like this, it's normally the side in the middle that you want to calculate, basically. Because if I work that out, it will be the same for the top triangle, won't it? So I now want to work out the side in the middle. So that means I've got 3 sides, 1 angle. That's cosine rule. So that's step 1. Let's bring cosine rule over here. Again, you might want to relabel, so just do this in pencil in your exam. You might want to relabel all the sides and angles to work with your cosine rule formula. The cosine rule formula is always based in the angle A, so the only angle we have is 105. That one will have to be angle A. Opposite side is then obviously side A, and then these other 2 can be B and C. So that one will be C, and then let's say if that was angle B, side B. And then we just fill it all out because we're looking for a side, so it's already in the correct format. And then I'm just going to type all of that into my calculator. But again, I've still got the other answer there with all the digits. So whenever it says 10.54, I'm going to use my answer button. So answer squared plus 11 squared minus, then the way I write it in the calculator is brackets, 2 times answer times 11 times cos 105, close the brackets, Now just remember though that this is not actually the side length, right? Because 292 doesn't make sense as a side length. That is the side length squared. Now you can write that down, or you can just square root it straight away, it's up to you. So obviously, square root, use your answer again, because now the answer is 292 ... And there is my side length A, which is 17.091 ... So if I label that, 09. Now, let's look at the top triangle again, because we've already done quite a lot of work, haven't we, for the 5 marks. So I want to find this side here. Let's rub out these again. I've now got 2 angles and 2 sides, obviously the one that I'm looking for included. So that's leaning more towards sine rule, 2 pairs, isn't it? I just have to check, do I have actual pairs, as in opposites? So what I mean by that is the 17 side is opposite angle B, so that works as a pair. And then here, angle C is in fact opposite the side I want, so that can be side C. So perfect. Unlike the previous one where I had to work out the third angle, this one I don't, because the pairs are already matching up. So for this one I'm going to be using B and C. Because we're looking for a side, I'm going to put the sides at the top. That's just how sine rule works. So side C I can put as X, or you can write it as AB if you prefer, over sine of that angle, which is 48, that's the opposite one, equals 17.09, which I will use my answer button for in the actual calculation, over the angle, so sine 118. Again, sin, cos, or tan always goes with angles that you have, degrees. Same as last time, I obviously want to know what X is, so I'm going to have to multiply by that denominator to move it across before I put it into my calculator. So that's what I'm looking for. Again, normal sine, not the inverse, because I know the angles and I'm looking for a side. So you can see I still got my previous answer, the 17.091 ... So I'm going to leave that there as my answer and put the A and S button so it copies everything across. I'm not rounding anything where possible until right at the end. Equals, now this is my actual final answer, isn't it? Because that was X. They've told me to round it to 1 decimal place. So that would be 14.4 meters in this case, isn't it? Let me redo that. That was meant to be meters. Meters, yep. So 14.4 meters. So again, another one where we had to use both sine and cosine rule, but also they threw in the area formula as well. You just had to reverse the formula. So there is a variety of the most common style of Edexcel trigonometry questions. If you want to look at anything else in trigonometry, especially being higher tier, the next video is now then the hardest Edexcel trigonometry questions. Otherwise, if you want to go back and recap trigonometry in general, I'll have everything listed down below in the description to go through some more straightforward questions on each of those individual parts of trigonometry. So thanks for watching. If you found this helpful, make sure to like and subscribe and leave down below any questions or comments that you might have.